Welcome to the course Biomedical Instrumentation and Sensors. I am Dr. Pankaj Kumar Mishra, currently working as a professor in the Department of Electronics and Telecommunication. Today, we will discuss about amplifiers. Now, what is an amplifier? An amplifier is a circuit is one which improve the strength of signal. The signal amplifier is a circuit that uses electrical power to increase the amplitude of an incoming signal, voltage or current signal and output this higher amplitude version at its output terminal. The ideal signal amplifier creates an exact replica of the original signal, that is larger but identical in every other way. In practice, a perfect amplifier is not possible, because no circuit can perfectly and proportionality scale up all aspects of a signal past a certain point. The amplifier are classified according to the many considerations that we will discuss one by one here. First one is based on the number of stages. Depending upon the number of stages of amplification, there are single stage amplifier and multi stage amplifier. Now, single stage amplifier, in single stage amplifier has only one transistor circuit, which is a single stage amplification. Second one is a multi stage amplifier. In this, the multiple transistor circuit we will use, which provides multi stage amplification. Now, second one is based on its output. Depending upon the parameter that is amplified at the output, there are voltage and power amplifier. Now, here the first one is voltage amplifier. The amplifier circuit that increases the voltage level of the input signal is called a voltage amplifier. Second one is a power amplifier. The amplifier circuit that increases the power level of the input signal is called as a power amplifier. Third one is based on the input signal, amplifier classification based on the input signal. Now, depending upon the magnitude of the input signal applied, they can be categorized as a small signal and large signal amplifiers. In a small signal amplifiers is one which, when the input signal is so weak so as to produce a small fluctuation in the collector current compared to its quiescent value, the amplifier is known as a small signal amplifier. In a small signal amplifier, the main factors that we are considered are amplification, linearity and gain. Now, here the second one is large signal amplifier, when the fluctuation in the collector current are large, that is beyond the linear portion of the characteristics, the amplifier is known as large signal amplifier. In a large signal or power amplifier handle relatively large voltage signals and current levels. The main factors that of this large signal amplifier are efficiency, maximum power capability, impedance matching to the output device. Now, next one is amplifier classification based on the frequency range. Depending upon the frequency range of the signal being used, they are audio and radio amplifiers. The audio amplifiers, the amplifier circuit that amplifies the signals that lie in the audio frequency range, that is from 20 hertz to 20 kilohertz frequency range, is called as a audio amplifier. Now, the radio frequency amplifier, the amplifier circuit that amplifies the signal that lie in the frequency range between about 10 kilohertz and 100 megahertz, is called as a radio frequency amplifier, or it is about 10 kilohertz to 100 megahertz. Next one is video amplifier. The video amplifier is an amplifier designed to amplify a band of frequencies from 10 hertz to 6 megahertz. Now, next classification is based on the biasing condition depending upon their mode of operation. There are class A amplifier, class B amplifier, class C amplifier and class AB amplifier. First one is class A amplifier. The biasing condition in class A amplifier or class A power amplifier are such that the collector current flows for the entire AC signal applied. The quiescent point is set or biased near the middle of the load line, so that at least half output signal swing may vary up and down without going to saturation or cutoff level. Its power efficiency is about 25% to 50%. Second one is class B amplifier. The biasing condition in class B power amplifier are such that the collector current flows for half cycle of input AC signal applied. The Q point is set or biased at the cutoff point and its power efficiency is about 78.5%. Class C amplifier. The biasing condition in class C power amplifier are such that the collector current flows for less than half cycle of input AC signal applied. The Q point is biased below 0 IB, that is located below the cutoff level. Its power efficiency is about 90%. Then class AB amplifier. The class AB power amplifier is one which is created by combining both class A and class B in order to have all the advantages of both the classes and to minimize the problems they have. The Q point is located at a DC level above the 0 IB of class B, but below the midpoint of the load line. Its power efficiency is about 50 to 78.5%. Now, another classification is based on the coupling method. Depending upon the method of coupling, one stage to the other, there are RC coupled amplifier, transformer coupled amplifier and direct coupled amplifier. Now, first one is RC coupled amplifier, a multi-stage amplifier circuit that is coupled to the next stage using resistor and capacitor combination can be called as a RC coupled amplifier. Next one is the transformer coupled amplifier, a multi-stage amplifier circuit that is coupled to the next stage with the help of transformer can be called as a transformer coupled amplifier. The next one is a direct couple amplifier, a multi-stage amplifier circuit that is coupled to the next stage directly can be called as a direct coupled amplifier. Now, next subdivision is based on the transistor configuration. Now, depending upon the type of transistor configuration, there are 3 types of amplifiers that are CE amplifier, CB amplifier and CC amplifier. First one is a C amplifier. The C amplifier, that is a common emitter amplifier, is a circuit that is formed using a common emitter configuration transistor. It is called as a common emitter amplifier. It gives a high value of voltage gain and current gain, and it has a 180, it will produce a 180 degree phase shift at the output. Now, second one is common base amplifier. The amplifier circuit that is formed using a common base configured transistor combination is called as a common base amplifier. Now, common base amplifier it will produce a highest voltage gain among the 3 configuration. Now, next one is a common collector amplifier. The amplifier circuit that is formed using a common collector configured transistor is known as common collector amplifier. It will common collector amplifier also called as a voltage follower. It will voltage follower or emitter follower. Its voltage gain is approximately 1. It will give a highest input impedance. Any transistor amplifier uses a transistor to amplify the signals which is connected in one of the 3 configuration. For an amplifier, it is a better state to have a high input impedance in order to avoid loading effect in a multi-stage circuit, and lower output impedance in order to deliver maximum output to the load. The voltage gain in power gain should be also high to produce a better output. Let us now compare the different configuration to understand which configuration suits better for a transistor to work as an amplifier. In comparison of common base, common emitter and common collector amplifier, in a common emitter amplifier the voltage gain is high and current gain is also high. In common collector the current gain is highest and voltage gain is approximately 1. In common base the voltage gain is highest, but current gain is low. So, all these 3 configuration we generally preferred to use the common emitter amplifier, since it will produce the highest power gain. The input impedance of the common collector amplifier is highest and the output impedance of the common base is highest among the 3 configuration. So, according to our need, we will use these 3 configurations in the cascading amplifier. Next one, the multi-stage transistor amplifier. In multi-stage transistor amplifier, the output of first stage is coupled to the input of next stage using a coupling device. These coupling devices can usually be a capacitor or a transformer. This process of joining 2 amplifier stages using a coupling devices can be called as a cascading. Now, the purpose of coupling device, the basic purpose of a coupling device are: first one, to transfer the AC signal from the output of one stage to the input of next stage. Second one, to block the DC to pass from the output of one stage to the input of next stage, which means to isolate the DC condition. Now, the types of coupling. There are 4 basic methods of coupling. First one is resistance capacitance coupling, that is RC coupling. This is the mostly used method of coupling, formed using simple resistor capacitor combination. The capacitor which allows AC and blocks DC is the main coupling element used here. The coupling capacitor passes the AC from the output of one stage to the input of its next stage, while blocking of the DC component from DC bias voltages to affect the next stage. Next one is impedance coupling. The coupling network that uses inductance and capacitance as a coupling elements can be called as a impedance coupling network. Next one is a transformer coupling. The coupling method that uses a transformer as the coupling device can be called as a transformer coupling. There is no capacitor used in this method of coupling, because the transformer itself conveys the AC component directly to the base of the second stage. This coupling is popular for its efficiency and its impedance matching. Hence, this type of coupling is mostly used. Now, next one is direct coupling. If the previous amplifier stage is connected to the next amplifier stage directly, it is called as a direct coupling. The individual amplifier stage bias condition are so designated that the stages can be directly connected without DC isolation. The direct coupling method is mostly used when the load is connected in series with the output terminal of the active circuit element. For example, headphones, speakers, etc. Now, the role of capacitance in the amplifier. Other than the coupling purpose, there are other purpose for which few capacitors are especially employed in amplifiers. Now, to understand this, let us know about the role of capacitor in amplifier. First one is the input capacitor C in. The input capacitor present at the initial stage of the amplifier couples AC signals to the base of the transistor. Hence, in C input, that is input capacitor, allows the AC signal from source to flow into input circuit without affecting the bias condition. Now, the second one, the emitter bypass capacitor CE. The emitter bypass capacitor CE is connected in parallel to the emitter resistor. It offers a low reactance path to the amplified AC signal. In the absence of this capacitor, the voltage developed across the RE will feedback to the input side, thereby reducing the output voltage, that is negative feedback. It will provide a negative feedback voltage series, or it is a voltage series feedback. Now, next one, coupling capacitor CC. The coupling capacitor CC is the coupling capacitor that connects two stages and prevents DC interference between the stages and controls the operating point from shifting. This is also called as a blocking capacitor because it does not allow the DC voltage to pass through it. In the absence of this capacitor, RC will come in parallel with the resistance R1 of the biasing network of the next stage, and thereby changing the biasing condition of the next stage. Power amplifier, after the audio signal is converted into electrical signal, it has several voltage amplifications done, after which the power amplification of the amplified signal is done just before the loudspeaker stage. Now, next type of amplifier is operational amplifier. Now, the operational amplifier, also called as an op-amp, is an integrated circuit which can be used to perform various linear, nonlinear and mathematical operations, and op-amp is a direct coupled high gain differential amplifier. The ideal op-amp attributes are: it will produce infinite differential gain, 0 common mode voltage gain, common mode gain, 0 offset voltage, 0 bias current, infinite bandwidth. The operational amplifier input attributes are ideal. Ideal operational amplifier input attributes are infinite impedance, 0 bias current, it will respond to differential voltages only. Operational amplifier do not respond to the common mode voltages. Now, the op-amp output attributes is a zero impedance. In spite of this, operational amplifier have the different configuration, that is inverting amplifier, non-inverting amplifier. It will use as a integrator, differentiator, or so many ways. The inverting amplifier, it will give a 180-degree phase shift. A non-inverting amplifier, it will have no phase shift. Similarly, the integrator, differentiator, the integrator will integrate the input signal, differentiator will differentiate the input signal. So, likewise many operational operations are performed by the use of operational amplifier. Now, next one is instrumentation amplifier. An instrumentation amplifier is used to amplify very low signals, rejecting noise and interference signals. Examples are heartbeats, blood pressure, temperature, earthquakes, and so on. Therefore, the essential characteristics of a good instrumentation amplifier are as follows. First one is the input to the instrumentation amplifier will have very low signal energy. Therefore, the instrumentation amplifier should have high gain and should be accurate. Second one is the gain should be easily adjustable using a single control. Third one, it must have high input impedance and low output impedance to prevent loading. Next one, the instrumentation amplifier should have high common mode rejection ratio, since the transducer output will usually contain common mode signals such as noise when transmitted over long wires. Next one, it must also have a high slew rate to handle sharp rise times of events and provide a maximum undistorted output voltage swing. Now, come to the next, that is advantage of instrumentation amplifier. The advantage of the instrumentation amplifier include the following. First one, the gain of a 3 op-amp instrumentation amplifier circuit can be easily varied by adjusting the value of only one resistor. Second one, the gain of the amplifier depends only on the external resistors used. Third one, the input impedance is very high due to the emitter follower configuration of amplifier 1 and 2. The output impedance of the instrumentation amplifier is very low due to the difference amplifier 3. The common mode rejection ratio of the op-amp 3 is very high and almost all the common mode signals will be rejected. Now, next one is application of instrumentation amplifier. The applications of the instrumentation amplifier include the following. First one, these amplifiers mainly involve where the accuracy of high differential gain is required. Strength must be preserved in noisy surroundings as well as where huge common mode signals are there. Some of the application are instrumentation amplifier are used in the data acquisition from small output transducer like thermocouples, strain gauges, measurement of Wheatstone bridges, etc. These amplifiers are used in navigation, medical, radar, etc. These amplifiers are used in to enhance the signal to noise ratio in audio amplification or in audio application like audio signals with low amplitude. These amplifiers are used for imaging as well as video data acquisition in the conditioning of high speed signals. These amplifiers are also used in RF cable systems for the amplification of the high frequency signals. Now, the types of amplifier, there are several types of signal amplifiers, each capable of conditioning different signals types. Here is a list of some common signal amplifiers found in today's data acquisition system. First one is differential amplifier, isolated amplifier, voltage amplifier for low voltage amplifier, high voltage amplifier, DC voltage amplifier or AC voltage amplifier, current amplifier, piezoelectric amplifier, charge amplifier, thermocouple amplifier, strain gauge amplifier, in bridge amplifier, full bridge amplifier, half bridge amplifier or quarter bridge amplifier. Reserving a signal essential characteristics, the specification of the signal amplifiers used in today's best DAQ systems are here are the elements that are most often specified, that are first one is input ranges, bandwidth and alias free bandwidth, sampling rate, gain accuracy, gain drift, gain linearity, offset accuracy, offset drift, dynamic range, noise floor, input impedance, maximum common mode voltage, isolation. Input ranges, the input ranges are the selectable input gains that can be applied to the signal. In a typical low voltage signal conditioner, these might ranges from 100 millivolt to 50 volt or higher with several steps in between. Bandwidth are also called the frequency response. Bandwidth is the range of frequencies within which a signal amplifier's performance is thought to be satisfactory. Sampling rate, the sample rate is simply the speed or rate at which the A to D converter within a data acquisition system can sample the incoming analog data from the signal amplifier. It is clearly related to the bandwidth. Now, next topic we will discuss in the next lecture. Okay, thank you.